Hi, hello everyone. So we'll start with the summary of week three, and I'll just share my screen. Wait,
Okay,
Good evening, ma'am.
good evening.
Good evening, ma'am.
Is my screen visible to all?
Yes, ma'am.
Yes, ma'am.
Okay. So week three is about quadratic equations. Firstly, we'll discuss what a quadratic function is. So a quadratic function is this sort of function. We've already discussed what functions are, right? So a special sort of function which looks like this, where your a, b, c are real numbers, right? These are real numbers, any real number. So these are arbitrary. You can choose any real number. Okay, and then a should not be zero. Most importantly, this should not be zero. Otherwise, this thing becomes linear. So this thing, ax, if you have a equals zero, you will get bx plus c, which is a linear equation, right? So this is linear function. This thing, this is a linear function.
Ma'am, I am at
And so, for example, you can take this is linear and a quadratic function. So one thing that you keep in mind is a, b, c are constants here, and only your x is a variable. So it's like this. For example, this 2x square plus 3x plus 1, where you can choose a, b, c and fix them, and x is the variable here. So this is a quadratic function, right? This is called the quadratic term. So your ax square is the quadratic term, and this is the linear one. And this is your constant term, right? And what does this represent? This graphically, this thing represents something like this. Either this thing, not exactly this. What we're trying to do here is we're just trying to broadly categorize it, or the downward one. So graphically, when you plot the graph of some of this function, this one or something else where A, B, C are something different, it will be something like this, which opens upward, or this, which opens downward, right? These are called parabolas. Okay, while discussing parabolas, we discuss other important terms. So first one is your axis of symmetry. So what is axis of symmetry? Axis of symmetry is, let's just say you have this thing. If you have, this is a parabola, let's say. An axis of symmetry is basically an axis. Like this is the y-axis, this is the x-axis. So you have an axis about which if you'll fold this thing. So let's just say if you fold this parabola about this thing, then these two branches will overlap. So this will overlap on this one if you'll fold it here. So if you have a paper and you'll fold that paper from here, this will overlap here. That's why this is called the axis of symmetry. So in this case, this is the axis of symmetry. Here, this is the axis, something like this. This is a very rough thing, only for you to know what this graphically means. This is the axis of symmetry. In this case, this is the axis of symmetry, right? And how do you find your axis of symmetry? So your axis of symmetry is, if we're taking the general equation where ax square plus bx plus c is your quadratic function, and then the axis of symmetry, because it looks like this. It's a parabola. So your axis of symmetry is given by x equals to minus b by 2a. This is your axis of symmetry, where we've already discussed this thing, how your x equals to something. This is a constant, right? So minus b by 2a is a constant. And if you have x equals to some constant, that line is parallel to y-axis. So it's going to
What
be
is the
something parallel to
equation of a
y-axis.
parabola?
Sorry, what? Is there a
What is the
doubt?
equation of a parabola, ma'am?
Equations, and we're only discussing functions right now. Equation is this thing. Equation is when you equate things. So if you put this thing equals 0, then it becomes an equation. So this is a quadratic equation. When you include the equals to sign, it becomes a quadratic equation. And this one is a function, a quadratic function. And this is the
Ma'am,
equation of,
in axis of symmetry, b upon 2a, what is b and a?
okay, b is the coefficient of x. If this is the general form of the quadratic function, then b is this, the coefficient of x. And a is the coefficient of x square. Is it fine?
Yes, ma'am. Yes, ma'am.
Okay. So while discussing the axis of symmetry, the b here is, we've already written this. If this is your quadratic function, then the axis of symmetry, let's just say it looks like this. We don't know what A, B, C are, so we can't exactly figure out what it looks like. But let's just say it looks like this. Then its axis of symmetry is going to be minus b by 2a, where b is the coefficient of x and a is the coefficient of x square. Then there is something called, so we're already familiar with the y-intercept, right? So if you have to find the y-intercept of this function, let's just say you have a function, this function. How do you find the y-intercept of it? So you put x equals 0, right?
Yes, ma'am.
You'll put x equals 0 and you will get y equals c. So this will be your y-intercept. Everything that we'll discuss in terms of arbitrary constant, it is as per this equation, ax square plus bx plus c. So c here is the constant in this equation. In this function, actually, this is not an equation. And then you have the vertex. So vertex is this thing. Your axis of symmetry is the axis about which if you fold, then these two branches will overlap. That's your axis of symmetry. So this is the axis of symmetry. And your vertex is this point. This end point. If you look at this carefully, for each point, you have a point here. For this point, you have a point here, which it will overlap with once when folded from here. So if you fold the paper from here, this point will overlap with this one. This point is going to overlap with this one, this point with this one. And this point is going to overlap with itself, right? It's not going to overlap with anything. That's your vertex. So this is your vertex of the parabola, which is given by, the vertex is minus b by 2a. And y you'll have to substitute. So y coordinate, so this is your function, right? How do you find the value of y when you have been given the value of x? Anyone?
Substituting the x value in the equation.
Yeah, so you put the x value here. It doesn't matter, by the way, but you can put this value minus b by 2a here in this equation, then you'll get the value of y. So all we're trying to do, you'll get some value of y. So this is going to be f by minus b by 2a.
Yes, ma'am.
But the main coordinate is this. This x coordinate is minus b by 2a. So this is what you have to keep in mind while discussing parabolas and while talking about parabolas. One last thing is upward parabola and downward parabola. So if you're in, this is the general form of parabola, right? This is how your parabolic function looks like. In plotting, it looks like this or this, and in equation, in functions, it looks like this, right? This is your parabola, and whether it looks like this, that means it opens upwards or it opens downwards, depends on your A. This thing depends on A. If your A is greater than 0, then your parabola, it opens up, it open upwards. And if your A is less than 0, then it open downwards. Is this bit clear to everyone?
Yes, ma'am.
Yes,
Ma'am.
Okay, how do you check it? Let's say, even if you want to check things, but look at this, let's just see the range and domain of this function. You have this function, and let's just discuss the domain of this first. So what do you think is the domain of this function?
the
Domain is the
input,
x that you can put here. Yeah. So what can you put in place of x so that this function is well defined?
real numbers,
Any real number.
Yeah. So all real numbers would be in the domain of this function. So
Yes, ma'am.
when you're discussing quadratic functions, the domain is real numbers. And what about range then? Okay, we'll come to range in a second. Let's just discuss this thing only. If you have A, let's just discuss why when you have A positive, why does it open upwards? So if your A is positive, what you're doing here is you have this thing. Let's just say either your parabola is like this or it's like this. We don't know yet. And you have been given this thing ax squared plus bx plus c. So you have to identify which one is it. Does it look like this one or it looks like this one? And you have been given that your A is greater than 0. So what happens is, let's just say this is your x-axis, and in this case, it's this. We just have to identify where it opens. That's it. So if your x tends to infinity, that means if you will take x here, here, then here, then here, if you keep increasing x, then this is going to be, it goes, what do you think will it go to? This function. Or let's just say, if your x goes to infinity, where do you think this thing will go?
Infinity.
Is this clear to everyone why this thing goes to infinity when x goes to infinity?
Yes, ma'am.
yes,
So simply what you do here is you see when x is increasing without a bound, that means your ax square is increasing, your bx is also increasing, and c is just a constant. So it doesn't actually affect anything. So why this would imply that your function also goes to infinity. In this one, where your function is this thing will also go to infinity. And when your x goes to minus infinity, what happens then?
Ma'am, can't predict.
Yeah. Okay, so let's just not predict from here.
In second graph,
If you just
will
put,
A
there's some confusion.
ma'am, I have a doubt. In second graph, you did A is greater than 0. Yeah. I think so. It will be A is less than 0, no, because it is
Opening
downward.
downward.
No, we're just trying to identify which one is the correct one in these two. Does it open upward, or we're trying to make sense of how do we come to this conclusion that A greater than 0 means upwards, A less than 0 means downwards. That's what we are trying to make sense of.
Finding
If
the
this is
vertex
the
point, right?
the vertex point it is, but we're not getting there. We just, vertex also depends on B. And we are only trying to fix things with A. Okay, we'll just come to this one later. This is upward. For now, you can just keep in mind that your A is, if is greater than 0, then it's an upward parabola. Looks like this one. Or if it's less than 0, then it's a downward parabola. And then we have the range of it. So if you have A here, then you have a fixed value here. So, okay, let's just come to this later on. And then about the range for this function. So in the range, you'll have real numbers, obviously. And then, so with real numbers, you take the values of fx such that your fx is greater than, either it's greater than the minimum value of f, either it's this one, or your range is going to be this one, depending on what kind of parabola are you dealing with. Whenever you have this thing, just tells you nothing. It just tells you that if you have, let's just say this is your parabola, it's a downward parabola, and this is the maximum value. So this maximum value is going to be minus b by 2a, right? And then this just tells you that the function's value, which is this, these all are functions value, these are going to lie below this value, right? So if this is, if this point is f minus b by 2a, then everything is going to be less than this thing, right? This point is f minus b by 2a, and all the values on this function are going to be less than this because this is the highest value.
Ma'am, I have
So
a
this
doubt.
yes,
In activity 3.7, question number 2.
we'll discuss doubts tomorrow. This is a summary session. Doubt session is tomorrow. Okay. So this is your range depending on if your parabola looks like this. If it's a downward parabola, then the range should be this. This should be the range for this type of parabola. And for an upward parabola, the range should be this one. For a parabola like this, your range should be this. Because then you'll have a minimum value. So an upward parabola only has a minimum value, doesn't have a maximum value, right? If you look at this one, you don't have a maximum value. You will just have a minimum value. And if you look at the downward one, this just has a maximum value. It doesn't have a minimum value. It keeps decreasing. And this one keeps increasing. That's why we've taken this thing that fx should be greater than f minimum. F minimum is this. So let's just try to find out if a function has a maximum or minimum. So, okay, if you have this thing, ax squared plus bx plus c, and your a is greater than 0, then will it have a maximum or a minimum?
Minimum.
Minimum.
will have minimum.
This will be an upward parabola. That's why
Yes.
it should has a minimum and no maximum. So it's unbounded above and bounded below. And bounded below by what? What's the minimum value it can have?
Ma'am, minus b by 2a.
So that's the value of x. That's the value of x.
Ma'am,
Why can't
f of minus b by a.
Yeah, if this is fx, then it should be f of minus b by 2.
Yes, ma'am.
That's the minimum value it can have. And if this is greater than, so if instead it has less than, then the things would have been opposite.
Yes, ma'am.
For a less than 0, it will look like this, and it's unbounded below,
Bounded above.
bounded above.
Bounded above.
bounded above by the same thing, by f minus b by 2a. So let's just do a question then. And you have to tell the vertex of this, axis of symmetry, and upward or downward. Three things you have to identify. What is the first one? The vertex is
Ma'am, vertex 3.
3.
3, ma'am.
okay,
Above,
it's
right?
3 then.
Ma'am, axis of symmetry 3, 0. And upward
Yeah, it's
opening.
x equals to 3 and then 3. If you have to find the vertex, this is axis of symmetry
Yes, ma'am.
and this is your vertex
Yes.
Upward.
Upward opening.
and upward parabola, right? And then what's the range of this one?
3 to infinity. 3 to infinity.
3 to infinity. Yeah, right. And how do we check this? You can just 3, 0 is its vertex. So 3, 0 is here. 1, 2, 3. It's here and it looks like this, right?
Yes.
Ma'am, 3
Wait,
is
then
on.
how is wait?
Ma'am, 3 is on the x-axis.
Yes, ma'am. 3 on the
Yes,
x-axis.
ma'am.
No?
3 is on the x-axis.
Yeah, right. Yeah. So you have 1, 2, 3, and then this opens upwards. This is it. And then its range should be 3 to infinity. So from here, 3 is attainable.
Its range should be 0
And
to
infinity
infinity.
is not 0 to
How we will,
infinity. Yeah, it's 0 to infinity. Right? I just got
how you
confused here. It's from 0 to infinity.
No,
If
ma'am,
this is if 3, 0 is the vertex, then it should be from 0 to infinity.
No.
how will
Vertex should be
continue
3, 0.
calculate range, ma'am?
Yes, the range started
What
from 0 and goes upwards.
what is
3,
this is
0
the vertex, right? Just confirm
Yes.
the vertex, that's it. If this is the vertex, then that's the range. It's from 0 to
Range
infinity.
started from 0 to infinity.
That's what we've written. Yeah, range 0 to infinity.
Plus minus infinity?
No, it's just infinity. It goes here now.
Okay.
Starts from 0 here and goes till infinity. This arrow means it keeps extending. This keeps extending, this keeps extending. Okay, so next up we have the slope of parabola. So before coming to the slope of the parabola, we'll discuss the slope of a line. So we've already discussed it in the last 2 weeks. So let's just say your line is this. Then the slope is this. Slope is given by m, and it's a constant thing here. So slope is constant.
And we'll continue calculate range through y-axis. No?
And graphically, it means what do you actually mean by the slope of anything? Let's just say you have slope of a function. Let's just discuss what a slope of a function is first. So a slope of a function is, let's just say you have fx. It just
Change
basically
in
means
x with respect to y.
it's change in y
Change in y with
per
respect to
unit
x.
change in x.
Unit change in x. Yes.
So if you have any function, so it should be it depends on the point, right? For a function, it's going to depend on a point. But for a line, let's just say you have a straight line. What happens is this means for per unit change. So if you change x coordinate by 1 unit, what should be the change? Unit,
This is
then the
also
change in y would be the slope of the function. Let's just say if you have this line y is equals to mx plus c, and if you change, let's just say this is your function. So if you change x by 1 unit, so you'll have x, and then you'll change it to say x plus 1 by 1 unit. So for this thing, you will have mx plus c, and for this one, you will have, so this is your y coordinate for this x, right? And your y coordinate for x plus 1 is going to be mx plus 1 plus c, and then you will subtract this thing. So this is change in y. This is y, or your f, this is fx plus 1, this is fx. The change in, this is change in y, and your change in x will be this. This is going to be 1, and this is going to be minus mx minus c. So this will give you m, right? This gets cancelled, this gets cancelled, so you're only left with m. So here, no matter what x you take, if you will make 1 unit change in x, the change in y will be, so this is 1 unit change in x, and this is the change in y then. So it's going to be m. So if you change x by 1 unit, then your y changes by m units, right? This is what it means. This is what slope means. But when you discuss a quadratic equation, a quadratic function, you have this thing, ax square plus bx plus c. So let's just say, instead of taking x and x plus 1, we take x naught. Let's just say you have this thing, and at x naught, you want to find the change, this thing. So what you do is you do fx naught plus h. So you take a point here. This is x naught. This should be x naught plus h, where we don't know what h is. H is something arbitrary. And here you should take x naught minus h. This is your point. This is another point, and then the rate of change or the slope at this point should be equal to f x naught plus h minus f of x naught minus h. If this is your fx, divided by x naught plus h minus x naught minus h. Is this part clear to everyone?
Yes,
Yes.
ma'am.
Yes, yes.
Okay.
Yes, ma'am.
So we get, instead of doing this whole thing, let's just start with x square first. Or should we do the entire thing because it's a long thing? We have x naught plus h whole square plus b x naught plus h. Just have to substitute this thing here in place of x. So instead of x, you will do x naught plus h. And this is, so x naught gets cancelled and you will have 2h here. And if you will solve this entire thing, x naught square plus h square plus 2x naught h plus b x naught h plus bh, no, bx naught and bh. And then for this, you'll have, we had a A here too. So you'll have A. And similarly, you will have here things as ax naught square plus ah square minus 2 ax naught h. And here you will have bx naught minus bh plus c. So the c gets cancelled there. This is very clear. Then bh, this will add up. So you'll have 2bh. Oh, wait. Ax naught square and ax naught square gets cancelled first. Then this thing, 2axh x naught h and this thing. These two add up and you'll get 4ax naught h. And then you have ah square and here you have ah square, so these two gets cancelled. Bx naught and bx naught are with the same, so these two gets cancelled. And then you have bh. Bh and bh add up to 2bh. So you'll have a 2bh here. And in the denominator, you have 2h. This will be 4a x naught plus 2b. And then you have the 2 in denominators. This will give you 2a x naught plus b. This is what you get. This is what you're going to get when you will do this thing. So at x naught, this is the slope at x naught, right? So this is f slope of f at x naught. This is 2a x naught plus b. And if you will use a general coordinate, so this was x naught is arbitrary, it could be any number. So you can just say the slope of the function at x naught, if it's 2a x naught plus b, then the slope of function for any x should be 2ax plus b, where your function was ax square plus bx plus c. So this is your slope.
But this also can be derived from differentiating the equation.
Yeah, it can be derived from differentiating as well, but we are not doing the derivatives here because not everyone is familiar with the concept of derivatives. Okay, then let's do one example here on what, just quickly tell me how the graph of this one looks like. What the coordinate that it passes through the vertex and if it opens upward or downward.
The downward. Minus 2a.
A becomes
Ma'am,
2.
upward. Ma'am.
Upward, A is 2.
Upward and upward.
Open upward, A is positive and slope is 2x plus 2. Vertex is minus 1.
Right, so this is, okay, if you look at this, you'll have
Ma'am, vertex is minus 1 comma
b
0.
by 2a minus b by 2a should be equal to minus 2
Ma'am, minus
by 2. So this
by
will
2.
give you minus 1.
Yes,
Minus
ma'am.
1 is here. And then because your a is positive, so it should be upward. This is how it should look like. An upward parabola with a vertex at 1. Okay, what about this one?
Ma'am, no intersection of x-axis.
Okay,
Open
Ma'am,
upward
above
vertex.
x-axis.
okay, it
Above
opens
x-axis.
upwards, and what about the vertex? Those two things are enough.
Vertex 0, open upward.
Vertex is a point, so it should have an x coordinate and a y coordinate. X is 0, right? What's y?
Y equal to
Y is
1.
1.
Y equal to 1.
Right. So it's this point 0, comma 1, and it opens upwards. How do you do this? This is, we know that we've already discussed that our vertex is minus b by 2a and f of minus b by 2a. So what you do here is minus b by 2a will give you 0. Just try doing it here, where a is 1, b is 0. That's why you're going to get minus b by 2a is going to be 0. And then f of
0.
0 is going to be 1. So your coordinate for the vertex is going to be 0, comma 1, and it opens upwards because your a is positive. And slope we've already discussed. So for the slope of line is constant. So each time there's a change of 1 unit in x coordinate, there'll be a change of m units in y coordinate. So y is equals to mx plus c is m, and slope of parabola, where parabola is like this, y is equals to ax square plus bx plus c is 2ax plus b. And then when you look at these things, let's just say you have this thing, and this is your vertex, this is your axis of symmetry. So if you have 2 points here, okay, let's just forget this thing. It's not that important. When we have quadratic function and their intercept forms. So a quadratic function in intercept form is when you write in standard form. Before this, we'll just discuss what standard form is. Standard form is,
ax square plus bx plus c.
yeah, but there are some conditions to it.
All must be
So the
integers.
first condition is a is
A not equal to 0.
not 0, right? And the second condition should be
A,
that
B,
your
C
a,
is
b,
real
c
number.
should be, no, they should be integers. Yeah,
Integers.
it's from the integers thing. That's your standard form for quadratic functions or quadratic equations, I'd say. And then for intercept form, you have this one. It looks like this: a x minus
P.
p and x minus q, where your p and q are what are p and q here?
Constants.
Ma'am,
Yes.
roots.
X
Root
intercepts.
constant, but
Zeros.
what other than that are they?
Intercepts of the
X
function.
intercepts.
Real
Right,
roots.
they are x intercepts. If you substitute x equals to q, you get y equals to 0. So they are x intercepts. Okay, and just try one equation where we'll try to convert quadratic equation into a standard form and standard form into quadratic equation. And let's just say you have something like, if you have standard form, you can only convert. First, we'll discuss the difference between an equation and a function. So equation and function is just this thing. Fx equals something is your function, where you have just the thing. Like when we discussed ax square plus bx plus c, so that's your function. But when you have an equal sign involved in this thing, then you call it an equation, like this thing: ax square plus bx plus c equals 0. Now this becomes an equation, and then we'll discuss zeros and roots. So when you discuss zeros, the roots you find of an equation. So if you've been given an equation, and the solution of that thing are called roots. And if you have been given a function, then the solution of those things are called zeros. So this is just terminology. Don't get confused here. So roots are of equations and zeros are of functions. Zeros are basically, if you'll put 0 of f is, if we say that x naught is a 0 of f, that means fx naught is equals to 0. That's what zeros mean. They do the same thing, but that's just the terminology that we use. This is it. And then let's just do one thing here, where we'll try to convert an equation from intercept form to standard form. So when you have standard form, I just mentioned that your ABC should be from Z, but that's not possible when you have a function. Let's just say you have been given 3 by 2 x square plus 1. Now, if this is your function, you cannot have these coefficients as integers, right? You can't change these things, otherwise your function is going to change. But if you have an equation here, then you can put it to a standard form, where what you can do is, instead of writing it this way, you can write it this way. Because multiplying by 2 on both sides of the equation is not going to change the equation. These two are essentially the same equations. Is this clear to everyone? So when I said that these three things should come from integers, I meant in equation form, these should come from integers. In functions, you can't really make this thing into an integer. That's not possible. If you have this, let's just say you've been given this intercept form, we'll try to convert this thing into standard form. So you don't have to do anything. You just have to multiply these things. It will give you x squared minus xn minus 5x. So this is going to be minus 6x.
Plus 5.
And this is going to be 5. So this is it. This is, and if you just multiply 3 here, you'll get the standard form, right? Because everything is an integer and it's fine. You can do this entire thing. Now let's just say that you want to go from intercept form, from standard form to intercept form. So what you do here is, let's just take an example first.
We will find the roots of the equation.
Yeah, that's one way to do it. You can find the roots and then you can, let's just say your roots are alpha, beta.
Alpha, beta, yes.
But the problem here is you'll do x minus alpha and x minus beta, right? But then this is alpha, beta, this is also a root of this thing, right? So you would not know the coefficient here. What you do here is,
How can we find
it that way
zeros of
too.
the polynomial?
The zeros of the polynomials are, let's just say you have a polynomial px. Zeros just mean x naught. If I write it in set form, it's a collection of x naughts belonging to real numbers such that your px naught becomes 0. You want the values of x, which when you will put in the polynomial, you will get 0. Those are called the zeros of polynomials. Zeros of polynomial p. Just try to is this thing clear? The zeros of a polynomial. The
Yes.
same thing as putting the polynomial equals to 0 and then finding the values of x. That's it. So if this is a polynomial, you just equate it to 0 and find the value of x for which this thing becomes 0. That's all. Those are called your zeros. Okay, so let's try to factorize this thing. factorize, you can call, or you can say that you try to convert it to intercept form. So what first thing that you do here is you have to take care of two things. First is 5, you do the product of these things, the coefficient of x square and the constant term. You take the product of these two, and then you take the coefficient of x, which is minus 30. So this is coefficient of x, and this is product of coefficient of x square and constant term. And then you try to find numbers. So this is going to be 30. This is 30, and this is going to be minus 30. So you have to find two numbers a, b, such that the product of AB is 30 and the sum of AB is minus 30. So what do you think can be those two numbers? We know that the sum is going to be minus 13 and the product is 30. So one hint is that A and B should both be negative, or they can't both be positive, right? Otherwise the sum is not going to be
Minus
negative.
6 and 5.
minus 10 and minus 3.
Right. So minus 10. And one hint for the negativity is that the sum of both of these should be negative and the product is positive. So if you have the product of two numbers as positive, sum of the two numbers as negative,
How
then those
A
two
plus
numbers
B
should be
become
negative.
13? Like coefficient of this thing, 13, A plus B. Can you clarify that?
We're not discussing why this.
No,
We're just
LHS,
trying to
LHS side.
find which one. This
No, that one. A plus B.
LHS or what?
30.
This one?
Yeah. Yeah. How we taking A plus B?
We're just trying to find two numbers.
Okay.
Find A and B. We're trying to discuss a method here. So what we're doing here is we're just trying to find two numbers A and B such that your product of AB is 30 and the sum of those two numbers is minus 30. So what we're trying to do is we're trying to convert this standard form into this form. A x minus p and x minus q. We're trying to convert this into this form. So for this, we're using this method where we take the product of these two, the coefficient of x square and the constant term. We take the product of these two, we get 30. And then we take the coefficient of x, which is minus 30. And we try to find two numbers A and B, whose product is 30 and whose sum is minus 30. Those two numbers are 10 and minus 3. Right? The product of these two is going to be 30 and the sum of these two is going to be minus 13. And then you just write this thing as, and you split this thing. So minus 13, your original equation was 5x square minus 13x plus 6. So you split this 13 into these two parts, 5x square minus 10x minus 3x plus 6. And then you can just simply take 5x common here. This is a way of factorizing things. So you'll have 5x here, 5 and x common, and you'll have x minus 2 here. Then minus 3 and x minus 2 here. Is till this step is my screen visible to all?
Did we just
Yes,
lost
ma'am.
you?
Yes, ma'am.
Yeah. So
Okay.
what was the last part that you guys were able to catch up to? What were we discussing? Till this part, was it clear?
Yeah, lastly, we are discussing two numbers which product is 30 and whose sum is minus 13.
So this is where I lost connection then, I guess. So what you do here is you split this 13 into minus 13 into two parts. These two parts. These two numbers that you found out, you use them here. So you split minus 13 into minus 10 and minus 3. So you write minus 13x as minus 10x minus 3x. And then you club these two together and these two together. So from here, you will take 5x common from this one, and you will be left with x minus 2. And from here, you will take minus is already common. So you will take 3 common, and you will be left with x minus 2. Here you will have a negative. Is this fine?
Yes, ma'am.
And then, because this is like this thing, AB plus CB, where you can take B common, and you can add these two things, right? Distributive property.
Yes, we got it.
That's what you do here. You will do f 5x minus 3 and x minus 2. So these are the two things you get from here. And if you want to write them in terms of x only, because you wanted to write them as this, x minus p and x minus q. So you can do this thing as x minus 3 by 5. Just divide this entire thing by 5, but then you'll have to multiply by 5 too. And x minus 2. So dividing this thing by 5, this thing by 5, and because you've divided this entire thing by 5, you need to multiply 2. That's all. So this now looks exactly of this form, the intercept form.
Can't we take 5x minus 3 is equals to 0 and then solve the equation?
Sorry, what?
Can we take 5x minus 3 is equals to 0 as an equation and then solve this equation
You can do
for
that
the
too.
answer?
That you can do, yeah. But then you'll have to, you want it in this form. So you'll have to make sure that your 5 is here. If you'll do 5x minus 3 here and then you'll put it equals to 0, you'll get what the factor you need, you'll get from here, x equals to 5 by 3. So you'll get x minus 5 by 3. But then 5 you'll have to take care of. We wanted to have the equation in this form, right? The intercept form. So this is the intercept form, where a is 5 and pq are these things, 3 by 5 and 2. Is this clear to everyone?
Yes,
Ma'am, ma'am, to find A, ma'am, in equation, ma'am, can we substitute P and Q as roots and then put the value of x in equation?
Okay, how do you know the roots of this equation? We've not discussed that yet.
Ma'am, after finding it, ma'am, ma'am, it's minus, ma'am, 2 and 3 by 2. 3 by 5.
Yeah, how do you do that? That's what's the approach that you're going to use? We've used this approach to find the roots too. So what you're doing here is, if you want to convert it into intercept form, then is when you follow this approach. Or if you want to find the roots, then also this approach works, right?
Yes, ma'am.
So if you're saying that, what was your question?
Ma'am, I equated, ma'am, 5x square minus 13x plus 6 is equal to a into a in bracket x minus 2 and in second bracket x minus 3 by 5. Ma'am, from where we can find a after putting the value
You
of
don't have
x in the
to do all
equation?
that. You can just, if you're already done this till this part, then why do you need to find? Okay, how do you find the roots then? Are you trying something else to find the roots?
No, ma'am. Ma'am,
So
in
you're
the
using
equation
this approach
5,
only.
Ma'am, in the equation 5x square minus 13x plus 6, we can find the roots of this equation.
How do you, other than this approach, how do you find the roots?
Ma'am,
Till this
from the
part, what
same,
we've discussed till
ma'am,
this part.
same approach. Ma'am, for finding A, I am saying.
Okay, but you don't have to do all this. What you're saying is that you can do A x minus 5 by 3
Yes,
and
3
x
by
minus
5.
2, right?
Yes, ma'am.
3 by 5. And then you'll equate it to this, what thing? This thing?
Yes, ma'am. 5x square minus
Or this,
13x plus
this
6.
thing. But isn't it going to be too much for you to,
Yes, ma'am.
okay, if you will do this thing, then isn't it going to be too much for you to first multiply this entire thing and then find A? Instead, you can just directly take 5 common from here because you want the coefficient of x to be 1. That's it. That's why you take 5 common from here and here. That will be
Oh.
easier, right?
Okay, ma'am.
Okay.
Well, what would the value of x?
Sorry, what?
What is the value of x? What is the answer? What is the value of x? We can.
Okay, we weren't actually trying to find the roots of this equation. What we were trying to do was we were trying to convert from standard form, we were trying to convert the equation in intercept form. That's all. So this is the intercept form that you get at the end. And from here, it's obvious that if you put x equals to 3 by 5, you get 0. That's one root, and then 2 is another root.
Okay, okay, got it.
Okay. Then this is also called the prime factorization approach. And then other way to find the roots is this is also one way to find roots. This is a way to find roots. And then another way to find roots is to by completing the squares. By completing the squares means, let's just say you have x square. Can we take a random equation? Anyone who can suggest a random equation? Okay, let's just take one known first. Let's just take this one first. And then we'll take something random. Minus 4x plus 4. Let's just say you have been given this thing. And you want to find the roots of this equation. One way is to do this approach, prime factorization approach, right? Yes.
This is the whole, this is a square, ma'am. This is the already a square.
I mean, square
Yeah,
of x minus
we
2.
start with, okay, we'll start with this thing. We'll see how we do the completing the square things, and then we'll find something which is not a complete square. Is that fine?
Yes, ma'am.
We'll deal with that example too. Okay, so starting with this one. First thing that you do is, so you have x square minus 4x, and so what we want to do here is we know that when we have a square of something, we want this thing, x minus a, and then a square of it. So you'll get x square minus 2ax, or plus, you can have a plus here, plus 2ax, and then a square, right? So we're trying to make it look like this one. So we have x square minus, and this one is minus 2a, right? And you here, the coefficient of x is minus 2a. Here you have minus 4. So if you try to write it, make it look like this one, you will have x minus 2. And then what's left here? To make it look like this one.
2.
Right, so you should write a 2 here. And another way to find it is if you don't want to get into this thing, what you can do is you can directly just, if you have this thing, you can take 2 and then take 4 by 2 here, right? So dividing by 2 and multiplying by 2. And then x. So this is 2, this is a, this is x. what you're trying to do here is you're trying to make this thing look like x minus a whole square, right? So in the process of doing this thing, your x minus a whole square or x plus a whole square looks like this thing. So x square you already have. The coefficient of x here is minus 2a, and here you have 4. So you want to make it look like 2ax. So 2 you take common from here. And then you divide this thing, because you're multiplying it with 2, you should divide it by 2 as well, right? That's why we've divided it by 2. So the coefficient, in simple words, you write the coefficient of x as 4 by 2. Or if you have b here, you should write b by 2. Let's just do a general one first. Let's just do this one. So if you've been given, let's just say you've been given ax square plus bx plus c instead. Now this is not a perfect square, right? We don't know if this is a perfect square or not. So what you do is you take ax square and then you do this thing, b by 2x and 2. You write this thing b as 2 times b by 2x, so as to make it look like this thing. 2 times, and then you do the b by 2 whole square thing here. Just add the square of this thing here and subtract the square of this thing here. Plus c is equals to 0. So let's just first check if this equation is balanced or not. If this and this are the same equations or not. Let's just not jump to this thing. Let's just do this only first. These two are the same equations, right? We've just divided this thing by 2 and then multiply it with a 2. That's it.
Ma'am, please write
then
again this equation. I can understand better than that way.
Yeah, we'll just write it here. We'll do it step by step. Ax square plus 2 b by 2x. And then so these two equations are same because we have divided this by 2 and then we've multiplied it by 2. So nothing changes. And what we do here is we just add b by 2 whole squared and subtract b by 2 whole squared, so that your equation is still the same. So this equation and this equation is the same because you added something and then you subtracted this thing. So it remains the same. And why are we doing all this? Because we want to make it look like ax square, or what you should have done is we missed that part here.
Ma'am, first we have to divide by a.
Yeah. You should have divided it by 2a. So that the coefficient. So first step you do is, let's just do this thing again. The first thing is you make the coefficient of x square 1. So you'll get this thing. These two equations are same. Then you divide and multiply by 2 here. And then you add b by 2a square on both sides. The square of this thing, or subtract and add the square of this thing. This thing. So it will be b
I
by
have a
2a.
doubt. Why we are dividing the B and C by A?
We're dividing it so that the coefficient of x is 1. What we're doing here is we're trying to make it look like this thing. You don't actually have to do this. We're trying to make it look like this. So the coefficient of x is 1. Even if you don't divide this thing by a, even if you don't make the coefficient a, this thing is still going to be valid. We'll do this thing when you don't divide it by a. That's fine too. That's going to work too. So here you'll have, actually there's no point dividing by a. We didn't actually need to divide it by a, but this is also fine. You divide by a, don't divide by a, it doesn't make a difference. So this is what you do. And then now, can you spot the square of something here? So if you'll take this term, these two terms, and this one. Do you see that this is a square of something? These
plus
two
b by
terms
2
and this term. So it's x plus, and how do you decide which one to take? This is the negative one, or what you're doing here is you're taking this thing, x squared plus b by 2ax plus b by 2a whole squared. This is what you're combining together, and these two you're not considering. So you decide this thing whether to take the positive one or the negative one by the sign of this. If you have a positive here, that means, but actually not, you're always going to take a positive here, because the square, when you take x plus a square, the square term for a is always positive, right? So this is always going to be positive. This is always going to be positive. So this is the square of x minus b by 2a plus b by 2a, actually, plus b by 2a whole squared. And here you have c by a minus b square by 2a equals 0. So from here you will have x plus b by 2a whole squared equals b square by 2a minus c by a. And then you can just take the square root of these things.
Ma'am,
4a square.
minus b square by 4a square.
We're just trying, what we're doing here is we're just doing the completing the squares part. You don't even have, we're not getting in the roots right now. We're just doing the completing the squares part. This
Ma'am,
is how you complete the square. You completed a square here.
So b square by 4a
That's what our
square, ma'am.
aim was.
That is b square by
Yeah.
4a square.
If you'll take it differently, then it's this, right? It's this. So this is how you complete the squares. Now let's just come to our example, which was x square minus 4x plus 4 equals 0. So how do you do this? So first take 2 common, then divide 4 by 2, so you'll get 2. And then you add the square of 2, so you'll get 4, and subtract the square of, by the way, you don't have to do it because you already have a 4 here. This is already a square. Even if you do it, you'll get this thing cancelled, and then this will be x square minus 2 times 2x and 4. So this is the square of x minus 2, right? Because this is, if you'll compare it with this form, x square, ax square plus bx, sorry,
2ab plus b square.
yeah, x square plus b square or a
Minus
square
2ab.
plus 2ax. If you'll compare it with
Minus
this thing, then your
2ab.
a square is,
minus 2.
Minus 2ab.
that doesn't really matter. Your plus minus thing is, so here the a is 2, so you'll get a 2 here. And because this is a negative 1, minus 2ax, so you should have a negative sign here. Does anyone have a doubt till this part?
Ma'am,
Then we can move to
can
something
you,
which is not a complete square. Yes.
ma'am, can you more elaborate this equation, like that way that you do derivation above and above process? Minus
Can
b
we take
upon
one more example of this these type of equations so that we can learn more of it?
Yes, ma'am,
That's
crystal
what
clear.
we'll do. This was already a complete square.
Yeah,
That's why
so
you
we
don't have to do
can
this
we take
entire thing.
yeah, so
Ma'am,
can we
Yeah,
take
we'll take
another
one example.
example?
where the ABC is present.
Let's take this one. Or anything that anyone wants to suggest. We can take anything random too.
Yes, ma'am, it's good example.
Okay, let's just start with this one. So first thing, And even if you don't take the coefficient thing was not really needed here. So even if you hadn't done the coefficient thing, that was fine too. Making the coefficient of x square 1. In this one, in completing the square, you don't really need to do that part. So this is, first you divide 10 by 2 and multiply it with a 2. So you'll get this thing and this. And then 10 by 2 is 5. So you have a 5 here. Add the square of 5 and subtract the square of 5. The 24 is already there, right? Where you'll have
25 is minus 1.
this is 25 square. We're keeping the 5 square here. We're clubbing it with this thing. And we're taking the other minus 5 square outside. Club the positive square with this thing. Make it a perfect square. This is x square.
Plus 5
This is 2.
square.
This is a. And this is a square. This will give you x plus 5 whole square. And this is going to be minus 25 plus 24. This
Can
is
we
this.
avoid taking plus 5 square and minus 5 square in the equation? Can we avoid taking that part?
That's what makes
can-
this square complete. You can't avoid this part. If you avoid adding it and subtracting it, then you are not going to get a perfect square. What we're trying to do is we're trying to make a perfect square of this. So if you don't have 5 square here, you'll just have this thing. And this is not a perfect square. Or you'll just have this thing.
To set the formula a square plus b square plus 2ab. That's why.
If you don't add these things, then you won't get this thing, x square plus 2ax plus a square.
Fine.
That's
okay,
why we're
got it.
adding and subtracting these things. Now you just take the square root. So this is how you this is the completing the squares process. And this is one way to find roots too. So if you have this equation, then your roots are going to be x plus 5, and then you take the square root on both sides. This is going to be x. Okay, the square root of this is going to be this, and this thing, this is actually equals to plus minus a. When you have a squared, or wait, not this thing actually. So you have to find x plus 5 such that the square of it is 1. This is going to be plus minus 1. Or you can say if you take the square root here, you can take the plus minus 1 here first and then take it here on the other side. Because the positive of x plus 5 is also going to give you, okay, the plus x plus 5 whole square is the same as minus x plus 5 whole square, right? So if this gives you 1, x plus 5 whole square gives you 1, then minus of x plus 5 square should also give you 1. That's why we take a plus minus here. And solving this, you'll get x plus 5 equals 1 and minus x minus 5 equals 1. So this is minus 4, and this will give you minus 6. So these two are going to be the roots of the equation that you had. Or if you'll try to do it with this one, x squared plus 10x plus 20. Let's just do it by prime factorization method. Now you already know what the ABs are. You can just see it from here. But if you have to take, you'll have to take AB such that the product of AB is 24. and the sum is 10.
12 2.
6 into 4.
There's a big hint here.
I'm 6 and
It
4.
should be 6 and 4. 6 and 4 when multiplied give you 24 and when added give you 10. So you should do it. And what's the next step? What do we do after this? You know
Plus
what A and
6x
B
plus
are.
4x.
So you split this into two parts, plus 6x and plus 4x. Then you take x common, whatever you can take common from here. You have to adjust it in a way such that you get a common thing here. So if you have something here, something here, you need something to be common. That's our aim. So what we're doing here is we take x common, so we'll get x plus 6.
Plus
When we
6.
take 4 common here, we'll get x
X plus
plus. So x plus 6 is common. You need this thing in order to use the distributive property, right? And then you do x plus 4. By prime factorization, you do it this way. The other one you did it by using the completing the squares method.
Ma'am, if we take 12 and 2, then it's the ये minus हो जाएगा. That's why we can't take it.
Yeah, if you'll have to take, so in order to take 12 and 10, you'll have 12 and 2, you'll have to take 12 and minus 2. And that's not 24, it's the product is minus 24. Or if the product is, if you take 12 and 2, then the sum will be 14. It doesn't satisfy both these equations. And then finally we have the quadratic formula. Okay, before discussing the quadratic formula, let's just let's just discuss the quadratic formula only first. Let's say you've been given this thing. And graphically, there's one more thing that's left to discuss, which was if you have this thing, then the slope is, how do you define slope?
By differentiation.
No, we're not getting into the differentiation part. How else do you define the slope of a curve? Fx. Anyone? We just discussed
2x
it
plus b.
some time ago. No, not of a
2x.
quadratic equation, of any function.
Changing y by changing x.
Yeah. Change in y by change in x. And any other way that you can define the slope?
Positive angle of tangent.
Yeah, so one way to define it is if you have fx and you need to find the slope. So only in the case of a line, your slope is constant. Slope in the sense, this thing is, if this is a line, then the change in x coordinate, the change in y coordinate, if your x changes, so if you have x here and you change x by 1 unit, the change in y is going to be 1 unit. This thing and this thing, here and here. This thing is 1. This thing is going to be n, right? So if this thing is 1, this distance is 1, then this distance is going to be this one. This distance is going to be n. Similarly, if you'll take something here, let's just say x0 and x1 here. So this is the change in y coordinate. And let's just say this change is 1 unit. That means x1 minus x0 if is 1, then this thing is going to be again m. This change is going to be m units. So for a line, it's constant, it's m. But for other functions, it keeps varying. So it depends on the point. Like if you have this point, the slope is something else. Here, the slope is something else. So here, what it means is it's basically, one other way to define it is that tan of theta that a straight line makes when it passes through this thing. So a straight line, if you have to find the slope at this point, then you just plot a straight line that passes through this point and touches this curve at exactly this point. And then you find the angle here, theta, and take the tan of it. That's your slope.
Ma'am, I haven't taken the parabola
That's another way to.
lesson. So can we take parabola from the basics, the initial from the initial stage?
Sorry, what?
I have missed the parabola session, so can we start from that?
No.
Once we complete this thing, then I'll just quickly recap that thing, the parabola thing. Is that okay?
Yeah, okay.
It's also
Okay.
streamed in YouTube. You can go there.
So the other way to define the slope is tan of theta. Theta is the angle that this line makes with this thing. This line that passes through this point and touches this curve at only this point. Okay, and coming to the quadratic formula. And there'll be times when you can't, while completing the squares, you can get something like this, right? And you get something. So in this case, you got, what did you get here? 1. There can be cases when you get a -1 here. That's when you can't find the value of x because you can't take the square root of -1. So what does that mean? If you get something like this, let's just say you get something like this, then how does the graph look then?
Ma'am, parabola
What does
will
this thing mean?
above x-axis or below x-axis.
Parabola not cut x-axis.
Yeah, right. This means that for no x, this actually means that if you'll put any x, you wouldn't get, okay. If you will take this thing, and this is your y, let's say, and you need to plot this thing. Its graph will look like the vertices are 5, -5, and 1. Right, so -5 is here, and then 1 is somewhat here. And it opens upwards. So this means it never touches x-axis. That's why for no value of x, you get this thing satisfied here. So no value of x satisfies this thing. That's because if x satisfies this thing, then that would have been this point, right? Let's just discuss we'll discuss the cases later. We'll first discuss the quadratic formula. So for quadratic formula, let's just say you have this thing ax square plus bx plus c equals 0.
One
So
question,
your quadratic formula, yes.
are you having it because that is where the graph is, or
मैम
question?
आपने -5, 1 कैसे लिखा मैम? ये कैसे आया?
Okay, that's when you have something like this and it's valid for for every function basically. When you have special type of functions, let's just say you have this function. So this is the line that passes through. You write it in this manner. It passes through, and you write it in this way. So it passes through 0 and c, right? So if you have c here, it looks like this thing. And it's the same for whenever you have this form of equation, what you do is y minus y naught
Madam, your
Then
voice is
I'll directly
breaking.
write it in this form if you have this thing. Of, is it fine now?
Ma'am,
Yes,
but
yes, ma'am.
Yes, ma'am.
You try to write it in this manner. So the main thing that you had, like in this one. So what this suggests is your y coordinate shift by y naught and your x coordinate shift by x naught. That's the shift.
ma'am,
If
but it's square,
yeah,
no?
let me complete first. Let me complete first. That's also y is equals to fx form, right? This is, let's just say you have y is equals to x square. Now this one looks like this. But if you have y minus y naught equals x minus x naught square, then its vertex shifted to y naught x naught y naught. So its vertex of this is, what's the vertex of this one? What's the vertex of this function?
Ma'am, 0, 0.
Right, this is 0, 0. And what's the vertex of this one? The vertex of this is x naught, y naught.
Yes, ma'am.
So this is the quick way to find out what the vertex of what the vertex of a parabola is. If it looks like this, the vertex is x naught, y naught. So this one here, it looks like y minus 1 and x minus of minus 5 and then whole squared. So the vertex should be the coordinate of the x coordinate of your vertex should be minus 5 and the y coordinate of your vertex should be 1. So you just have to look what is subtracted from y and what is subtracted from x. That's all.
Yeah. Ma'am, what is vertex, ma'am? It just curve, lowermost point or the uppermost point.
If you have something like this, then this is the vertex. And if you have this, it's basically the point from which when you will draw a straight line, you can fold this thing.
Symmetric. Okay.
Yeah, it's symmetric.
So,
These points
okay.
will
So,
overlap each other after folding.
Also, if you
ma'am,
could
just,
discuss
ma'am,
maximum
just,
and minimum.
ma'am, scroll down, ma'am. Just little bit scroll down. Okay, ma'am. Little more. Oh, wait. Ma'am, where you written the जहाँ पे आपने ड्रा किया ना लाइन को, जहाँ से 0, C से स्टार्ट होता है, उसके बाद आपने x, y पे वर्टेक्स दिखाया, वो कैसे? हाँ, x naught y naught वर्टेक्स कैसे हुआ?
Okay, let me just repeat this thing here.
Can we
When you
start
have,
the parabola from the start now? Because
we were left with quadratic form, the quadratic formula. We don't have, if we'll get the time to discuss it, we'll discuss it in the end. Otherwise, we'll just discuss this thing first.
Just one question.
And the one thing that I'll just discuss, 1 second. Yes.
Ma'am, can you write y naught, x naught, y naught vertex? How I write?
When you have this form, let's just say you have, okay, what was the, let's just take up a random question, x square plus 2x plus 3. Let's just take this one. I'm not sure if you're going to get a perfect square or not, but let's just try this thing. Let's just say you have this. And then you need to find the vertex of this. So what you can do is you can quickly complete the squares. This is going to be x square plus, so this is 2x, and here you should have 1, right? So you'll add 1, subtract 1, and you will get 2. This is going to be x plus 1 whole squared, and this is 2. We've done nothing, we've just completed the square, that's all.
I didn't get it,
So
ma'am.
this is,
Ma'am, excuse me, ma'am. You have written
yes,
x square plus 2x plus 1 plus 2. So 2x plus 1, how you can write it 2x plus 1? Because the value is 2x itself. How can we write
we've
2x
done
plus
this
1?
using the, we have done this using completing the squares method. We don't have enough time to discuss that in detail right now. Just do you'll do 2, divide this by 2, multiply it by 2, right? You'll do all that. Then you'll, okay, let's do it. If you have this thing, you'll do x square plus You divide this thing by 2 and multiply by 2, right? So it doesn't change anything. It will give you the same thing. Dividing this by 2 and then multiplying by 2 gives you the same thing, 2x. And then what we used to do was, we have a 1 here now. 1 squared, you will add, and then 1 square you subtract. Then you already had 3. So this is what this becomes. And then this is x plus 1 whole square, this entire thing. And this is minus 1 square plus 3. So it gives you 2. Is it fine now? You've just done the completing the square
Yes,
root,
ma'am.
right?
Yes.
That's all.
Yeah, yeah.
Nothing else. So from here you get y minus 2x plus 1 whole square. This function, this which we had initially, it looks like this thing. So its vertex is at minus 1, comma 2. How do you decide this? Because it's y is equals to x square has its vertex at 0, 0. And y minus a equals x minus b whole square. You should take b here and a here.
बट मैम +1 ना, तो आपने -1 कैसे लिखा? और -2 था तो 2 लिखा ना?
Minus
In
minus
equation.
plus.
Vertex of this thing is a comma b. Is this thing clear? The vertex of this is 0, 0. Vertex of this is x, and then what is subtracted from x? A is subtracted from x. The x coordinate of the vertex is a. B is subtracted from y. The y coordinate of the vertex is b. What is subtracted from x here?
What मैम? Actually add 1.
This is the same as x minus minus 1. So minus
Okay.
1 is subtracted from x.
Okay.
That's why the x coordinate of the vertex is minus 1 and the y coordinate is 2, because 2 is subtracted from y.
Okay. Ma'am, can you wait, ma'am? Just focus on this, ma'am. Ma'am, please, ma'am. थोड़ा बस ओके मैम, यहाँ पे मेंशन कर दीजिए दिस इज वर्टेक्स फार्मूला मैम, ताकि मैं इसके साथ ले सकूं, बाद में याद रख सकते हैं. जस्ट व्हाट्स द वर्टेक्स फार्मूला, जस्ट इन अ शॉर्टकट. ओके. Okay,
This
thank you, ma'am.
fine now.
Okay, ma'am, thank you, ma'am.
Okay, let's just come to the quadratic formula then. If you have something like this, ax square plus bx plus c, as we already discussed, we first take this thing here, and then we try to complete this. By completing the square, we've already done this. It follows the same approach. So in completing the squares, and the thing that we got was x plus b by 2a. And here we got b square by 4a minus c by a, I guess.
4a square, ma'am.
Okay, 4a square, right? This is what you get. So I just, okay, so here you will get e, or we just avoid this thing. We'll take the square root of it then. So you'll have b square minus, and if you'll take the LCM of this, you'll get 4a square, right? So the LCM is going to be 4a square. And here you'll have b square, and here you'll have
Minus 4ac.
4ac, right?
Okay, Siddharacharya
These
equation. Okay.
things together. And this is going to be b square minus 4ac by 2a. Then you have a plus minus here. And then you will have this thing plus b by a. We had a b by 2a here, right? B by 2a. This will give you x equals b plus minus square root of b square minus 4ac by 2. Okay. This is going to be the value of x. And this is your quadratic formula. So you don't have to complete the squares every time. You can just directly use this formula to find the roots. And it is derived from completing the squares only. So let's just say you have been given x square plus 5x plus 27. Then the roots of this are going to be 5. So b is 5, a is 1, and your c is 27.
27.
This is going to be, let's just take this one negative.
25 minus 27.
We'll have b square, which is 25. Then we'll have minus 4 times a, which is 1. C is minus 27.
108.
By 2 times.
Minus 5 plus minus.
108.
I don't think this is a perfect square. It's going to be
133.
This is not a perfect square, but
Okay.
this will be your solution.
Uh,
It's 182.5 plus square root of
11.5.
133 by
11.5 something.
2.5 minus square root of 133 by 2.
Ma'am, minus 2.5.
Yeah, minus we have a minus here. Because we have plus here. It should be minus. It should be minus 2.
Just more calculative way to, I think.
This is
pretty
it.
lengthy,
Use your. This is lengthy, but this is the only way that you can find the root of this equation. If you try any other method, you won't be able to find the root of it. So sometimes only quadratic formula works and no other formula. What we've discussed so far is one was prime factorization. It's not going to work in this case.
trial method.
And then the other one was
please
completing the
scroll up.
squares. Completing the squares is the same as this quadratic only. And then the other one is your hit and trial. Just 1 second. Just 1 second. Hit and trial is, it rarely works. Can we move ahead? Is this clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay. And then we have
minus
so this is
2.5. Like how we get minus 2.5?
Someone video is open. Please mute it.
okay. So this minus 2.5 you get from the you just have to put the values of this in the equation. So b is 5 here. That's why you get minus 5 here. Minus b is minus 5. And minus 5 by 2 is minus 2.5. That's how you get 2.5. Minus 2.5.
Ma'am, in which what is the particular
And then
formula
this
for
thing, so in
discriminant?
your quadratic formula, this is your quadratic formula. Yeah, we'll discuss that thing here. The discriminant is this thing, b square minus 4ac. And
Yes,
if your
ma'am.
discriminant is positive, so if your discriminant is same, it's the entire thing. Actually, this one only. It's without the square root. If your discriminant is greater than 0, that means it's a perfect square, right? Like not perfect square exactly, but it's still possible to take the square root of it. Like 5 is not a perfect square, but you can take the square root of it, right? It's a real number. This is a real number.
Those roots are real.
But if you will take -5, let's say b square minus
Means two
4ac is,
real roots.
yeah, this is going to be complex.
Ma'am, your voice is actually lagging sometimes. So if you
So let's make a table here. Let's just say if you have b square minus 4ac, and this is greater than 0, and then there are two cases to this. One is when b square minus 4ac is a perfect square.
Ma'am, if less than 0,
And yeah, we'll come to that later. First, let's just discuss this. B square minus 4ac is not a perfect square. These are two cases, and then the other case is when this is less than 0. So when you have this thing less than 0, that means in your quadratic formula, you can't take the square root of it, because you can't take the square root of negative numbers, right? If you have -5, you can't take the square root of it. Like, you can take the square root of it, but then it won't be a real number. So to discuss real numbers, because we're only discussing real numbers, then you won't have a real root. So when this happens, this implies no real root. And when this happens, this implies that you have a real root, but it depends. If you have b square minus 4ac as perfect square, then this will imply that your root is rational. And if this happens, then your root is going to be irrational. And if your b square minus 4ac is 0, this means you have repeated roots.
And if all the formulas, other formulas, the square method and all fail, then we can find with this formula of quadratic formula the roots, and we can come to the conclusion.
Yeah, that's
Right.
your last resort. Yes, that's your last resort. If nothing works, this is definitely going to work. The quadratic formula. Okay. Are we missing anything from here? From this quadratic
Voice is lagging, ma'am.
functions? Anything that anyone wants to ask?
ma'am, your voice is too much lagging, ma'am, like a horror movie.
solving by factoring is the best method, I think.
Should we prefer quadratic formula over other methods?
Disconnected. Time is also limited.
Trimurti, are you there?
I think we lost her.
Where you-
Internet
Trimurti
connection.
है क्या?
She is facing some issue. Huh?
त्रिमूर्ति
जल्दी मैडम चला गया का भाई?
कैसे हो मिश्रा भैया?
ठीक हो? वो कहा यार, त्रिमूर्ति नहीं हो गया?
यूट्यूब चल रहा है?
गई मैम गई।
ओ मिश्रा भैया।
तुम
Is the
अपना ग्रुप
session
नहीं
over?
बनाते थे?
Yes, you go now.
मिश्रा,
हाँ
आप लोग अपना कुछ ग्रुप नहीं बनाते? जैसे कि कुछ अगर कुछ प्रॉब्लम हो तो हम लोग अपने में डिस्कस कर पाए।
ऑलरेडी है ब्रो, ऑलरेडी ग्रुप है ना, हम
हाँ
ऑफिशियल बना के तो रखा है।
यार, तो हम लोगों को बनाना लाइव वाले अलग रहने चाहिए भाई। हाँ बनाओ यार, कोई हमने
हाँ
बनाया है, टेलीग्राम
उस
पे बनाया भाई।
Yeah,
नहीं
यार मैंने
करके
कोई
किया।
अगर
होगा
ग्रुप
पता है।
ये रुको, मैम आ गई। हाय मैम।
नहीं आएगा।
अच्छा
नहीं
ठीक है,
आई
बोलो
मैम नहीं।
कंटिन्यू। हाँ बताओ
हाँ
भाई।
मिश्रा, आप बनाइए ग्रुप तो कि हम लोग डिस्कस
हाँ
कर पाए।
अरे ऑलरेडी है ना ब्रो।
तो वो तो
भाई व्हाट्सएप पे
वो तो
नहीं है।
बहुत स्पैम आते रहता है,
हाँ व्हाट्सएप पे
बहुत
नहीं भाई।
सारा। हाँ, उसमें
भाई
खाली
व्हाट्सएप
डाउट्स
पे
वगैरह
हाँ।
डिस्कस कर पाए,
ओके हाँ,
कुछ भी
टेलीग्राम पे,
अगर।
ओनली टेलीग्राम। एक्चुअली क्या, दिस इज माय मदर फोन, so my sometimes my mother using this, so I was afraid it no, you can understand। ये
भाई
देखो,
अपना
ये
अपना
मेरे
कैमरा ओपन करो। भाई नहीं यार, ये तो जबरदस्ती क्यों बोल रहा है यार?
मैं
शायद
ऐड में
यूट्यूब पे भी लाइव है भाई,
अबे
देखना
कोई
पड़ेगा।
ना
नहीं यूट्यूब पे भी है शायद, चल रहा है
यार।
शायद यूट्यूब पे।
मे आई शेयर माय लिंक इन दिस टेलीग्राम, लिंक
फॉर
शेयर
द
करो भाई।
ग्रुप।
टेलीग्राम पे सिक्योर रहता है भाई, और वैसे भी व्हाट्सएप हटने वाला है देश से।
है भाई है, यूट्यूब पे है लाइव अभी।
अपना चैनल का नाम बता दो, मैं ये कर लूंगा।
अभी हाँ इधर को बता रहा हूँ भाई। मैंने बनाया उसमें काफी ज्यादा।
Yeah, sorry.
हाँ भाई, स्यूडो आईटीएन है, स्यूडो आईटीएन।
मैम आ गई।
रुको मैं
मैम
शेयर
आ
कर
गई।
रहा हूँ,
ये
स्यूडो
मैम आ
आईटीएन।
गई।
Ram is
सी सी
connecting. Please,
मैम
please
कनेक्ट।
stop.
So let's quickly check
मैम,
my
दिस इज द बेस्ट मेथड मैम। मैम नहीं आई, मैम ने रिप्लाई नहीं दिया।
wait a minute.
है।
Wait.
ले भैया अब बोल।
So uh, what were we discussing? The last thing that we were discussing was
Ma'am, I have a query. Should we prefer quadratic formula over other methods?
if you want an answer, then that's the best way to do things because you will definitely get an answer from there. The other methods might fail. We did an
Okay.
example
Thank you,
where
ma'am.
we got the root as -2.5 plus square root of 133. That solution you can't get from other methods. Only quadratic formula can give you that answer. Anything
Okay,
else
thank you,
anyone wants to ask?
No, ma'am. No.
Okay. So can we wrap up the session then?
Yes, ma'am.
रैप
डाउट इन
Yeah.
Sorry, what?
स्लोप ऑफ अ पैराबोला मैम।
What about slope of a parabola?
Yeah, so you said us like in a particular point where it makes an angle, we can actually say it is equal to tan theta. But in each point, slope differs for parabola right now. I'm
Yes,
bit
it
confused
differs.
between.
For each point, it differs. You can't have the slope of a parabola differs everywhere. You can't have the
Okay,
same slope at 2 points in a parabola.
okay, but
In
you
case of a
drew a
parabola.
diagram showing a line in the like 45 degree making angle 45 degree in a slope you showed right now. You
Yeah,
said it is
yeah,
the
we drew a
slope of
diagram and yeah.
yeah, ma'am, like how it is then possible like we can say it is tan theta that point.
What's your question?
So like it can't be equal at parabola can't be equal at every single point. It differs at parabola, right, ma'am? That's what like
No, the slope is actually the change. Either you describe it in two ways. Either you say that it's the change in y coordinate,
x
when your
coordinate.
change in x coordinate is one unit. That's one way to define this. And the other way to define is that you at a point, if you have to find the slope at a particular point, that's how you describe about the slope. So
dy
when you have
by
to find
dx.
the slope of a Then you have to find the slope of a,
I ask a question.
yeah, 1 minute. Let's just discuss this question first. Then it's, if you know what angle does the tangent. So tangent is a line that touches that graph at that point where you want to find the slope. So let's just say you have to find the slope at x naught, y naught. You draw a line that touches the graph only at that point. And then you see the angle that the line makes with the positive direction of x-axis. And then you take the tan of it. That's two ways to define the slope of a function, of any function. So for a parabola, if you have two different points, you cannot have the same slope at two different points.
Okay, ma'am.
So the point वाइज स्लोप इज क्या कहते हैं वो बदलती है तो मैम कैसे मैथमेटिकली इसे ड्राइव डिफाइन कर सकते हैं dy by dx
What?
Suppose there is a
What is the difference between vertex of parabola and axis of symmetry?
Axis of symmetry is like y-axis is an axis, right? X-axis is an axis. So it's a line that extends in both directions, on the positive direction and on the negative direction. That's your axis. So a straight line parallel to y-axis is your axis of symmetry. And the vertex is that point. So vertex is a point and axis of symmetry is a line parallel to y-axis.
Which divides in two symmetrical parts.
Yeah, it divides
I
the
see.
parabola in two symmetric parts.
Yes, I get the point. Okay, thank you, ma'am.
Okay, anything else?
Ma'am,
Ma'am,
why the
suppose
sign?
Yes.
Ma'am, why the sign of A decides the opening upward or opening downward of parabola?
Okay, so if you'll have, can't share my screen right now. I remember we decided to discuss it at the end. So if you have
Yes.
ax square plus bx plus c, this is the parabola, let's say. And a, if it's greater than 0, what happens is, let's say you have x, right? And x is a huge number. So when x tends to infinity or when x tends to minus infinity, what happens is the coefficient of x square decides where it, okay, if you have ax square, then the coefficient of x is not going to matter because for large numbers, let's say you have 200, 300, and even larger numbers, x square is going to be greater than x, right? For large
ma'am.
numbers, let's say you have huge numbers, something greater than 1, let's say x is greater than 1, then x square is going to be greater than x, right?
Yes, ma'am.
So let's just say your b is negative and your a is positive. You have ax square plus bx plus c. So you agree that the sign of c is not going to change the direction, right? That you agree with. Because c is just a constant, it's a small number. It's not going to decide anything, right?
Yes, ma'am.
So let's say a is positive, b is negative. Then our confusion is, the conflict is if x tends to infinity, then
Yes,
your
ma'am.
confusion would be that ax square would be positive term and bx would be a negative term, right? That's the
Yes, ma'am.
problem. But x is the smaller number here. So as x tends to infinity, x square is greater than x.
Ma'am, at infinity,
we
how can we
discussed.
define? How can we decide
not-
at infinity, ma'am?
What does infinity means? Large numbers, right? Very large number.
Yes, ma'am.
So if you have something, let's say you have 1000.
Yes,
Okay,
ma'am.
let me just. If you have 1000, then the square of 1000 is going to be greater than 1000. So what happens is ultimately your ax square is a very large x. Ax square is going to be greater than bx.
Ma'am, what if x is in fraction?
X is in.
Ma'am, a square of fraction, ma'am, always less than the original number.
You're not getting my point. My idea was when we were discussing a parabola, what I meant was when you have a parabola, when x tends to infinity, if your a is positive, if your x tends to infinity, the whole parabola the y is going to tend to infinity. So ax square plus, if x tends to infinity, a is positive in the parabola equation, and ax square plus bx plus c is going to infinity.
Yes,
And
ma'am.
same is the case with if x is going to minus infinity, your ax square plus bx plus c is going to infinity only, because your a
Excuse
is
me, ma'am.
positive. Yes.
Ma'am, are you sharing your screen?
No, I'm not. I can't share my screen right now.
Yeah, okay.
Continue.
Just wanted to
Please don't
confirm.
disturb. Please don't
No, I'm
disturb.
not disturbing. I'm just confirming.
Just mute.
Just
Okay, let's not argue here. So
Ma'am,
what you
when we
have,
use completing the square method, when we use,
completing the square method is one of the, okay, it's, you generally don't use completing the square methods. The quadratic formula is a better option because quadratic formula is an extension of completing the square.
yeah.
When we derived the quadratic formula, we used completing the squares part. So if you have to find the roots, you can directly use the quadratic formula. Or if you do it by completing the squares, you will have to ultimately go through quadratic formula only. Because quadratic formula is derived, it's the extension of completing the squares method to find the root.
Yeah.
Ma'am, why do you ask actually if the quadratic formula like ax square minus bx plus c, then what happen if ax is a huge number and b is lower than a? That means what happened? This is that the question he is asking.
That's no one's asking that, I guess.
Then what you
Ma'am,
what you
I'm sorry, may I have your time?
Yes.
Ma'am, so is it a compulsion to just take the form do that f of x plus h and do that slope, or else directly we can take the derivative, ma'am?
You can directly take it. You just know that the derivative is 2. If it's ax square plus bx and c, then so you can directly take 2ax plus b. That works. You just need to
Okay,
know
ma'am.
that that's the slope. That's the equation of the slope.
Okay, is it not compulsory to do that big long method every time?
No, you don't have to do that.
Okay, thank you, ma'am.
Okay. So the only part that we missed in the beginning was about that how does the sign of A decide everything? Is that part clear to everyone?
Ma'am,
Because ultimately,
can we decide it by that formula which you said how to find vertex? Ma'am, that is
Ma'am, can we discuss the parabola topic again in the next session
yeah,
from the
sure.
very basics?
And yeah, we can, that's okay, we can discuss that. When we'll do the doubts, you'll be familiar with that too. Doubts will cover everything.
Okay.
Okay.
can we decide ma'am, can we decide the side of parabola by vertex formula?
Vertex, which one? Which one's the vertex formula?
Ma'am, y minus k equal to a in bracket x minus alpha square.
Yeah, you can decide it by that. What you do is, let's say you have y minus alpha equals x minus beta whole square, right? So you just have to check the sign of x square. The term in square, that sign you have to check. So if it is y minus alpha equals x minus beta whole square, then it's an upward parabola. But if it's y minus alpha equals minus of x minus beta whole square, so if there's a minus in front of whole square, then it's a downward parabola.
That means y minus k equal to a in bracket x minus beta whole square.
Yeah, y minus, you're saying y minus k equals a and then x minus beta in whole square. So you have to check
Yes.
the sign of a. A
Yes,
decides
ma'am.
if it's upward or if it's downward.
Yes, ma'am.
If a is positive, then it's an upward parabola. If it's negative, then it's a downward parabola in this case.
Yes, ma'am.
Okay, anything else?
No, ma'am. Thank you, ma'am.
Okay.
We will be discussing turning points tomorrow.
Turning points, is that a part of week 3? Because
Yes.
in quadratic functions, you just have, you cannot have more than one turning point. Because a parabola can have only one turning.
Yes, yes.
It's polynomial function.
It will be there.
Yeah.
Okay.
For a polynomial, we'll discuss it when we'll discuss polynomials. That's in week 4, I guess.
Okay.
Okay. Anything
Okay,
else,
ma'am. Thank
guys?
you, ma'am.
Lastly, you explained the conditions of discriminant.
Yeah,
Could
is
you
there a doubt?
explain again?
I can't share my screen right now. I'll just verbally tell you what it was. So if your discriminant is b square minus 4ac, that thing is positive. That means you have a real root for the quadratic function, quadratic
Greater
equation.
than 0.
Yeah, if
Right.
it's greater than 0, then you can take the square root, right?
Yes, ma'am.
That means you have a real root. If it's less than 0, then you can't take the square root. If you'll take the square root, it will be an imaginary number, complex number. So you won't get a real root. Your roots will be complex,
Yes,
not
ma'am.
real. So if you have negative discriminant, your roots will not be real.
No real roots.
Yeah, in that case, the parabola won't touch the x-axis. It will be either it will be completely above x-axis or it will be completely below x-axis. It won't touch it.
Yes, ma'am.
In this case, when you have imaginary roots, complex roots.
Okay, ma'am. Thank you.
And then the other one's just equal roots. When you have the discriminant equals 0, then you have
Equal
two
to
equal
0.
roots.
Equal to 0.
Yes.
Yes, ma'am.
That's all. That's about discriminants. Anything else?
No, ma'am. Thank you.
Okay.
Thank you so much.
Okay, thank you guys.
Thank you, ma'am.
Trimurti.
निशा तुमने जो शेयर
हाँ
किया था ग्रुप का उसमें मैं
हाँ तो
अपना
मैंने
डाउट भेज चुका हूँ
सर वेट जस्ट मैंने वो
Any
शेयर किया था
working
टेलीग्राम
professional here?
वेट क्या
मैंने पूछ रहा हूँ any working professional here? Look, anyone who's really working?
I think there are so many person are working
So how will you guys manage?
कौन सा कमेंट भाई त्रिमूर्ति